Hello, everybody. I am very glad to be here. I'm very excited. That's my first webinar, so you get to experience that with me. I'm, as was mentioned in chat, I'm the newly minted CWNE number 550. I have 25 plus years of experience. I've worked in several verticals, and in each one of my jobs, I've been responsible for the Wi-Fi network. And I hope today to give some Wi-Fi tips and tools to help wired network engineers work through wireless specific issues. Wi-Fi gets added to our bucket by default. You handle the network. This is more networking, so you get to handle it. After all, you have all the tools and the training already, right? Sure. Let's start with what businesses expect from the Wi-Fi. Employees and guests expect hassle-free connectivity throughout the facility. Employees expect to be able to use every app seamlessly at their desk, in a conference room, and while roaming the hallways. Remote users expect to connect from home, at a hotel, or in the airport with the same reliability they get in the office. All of this expectation disregards the client that they're using, the number of users around them, if the wireless network was built by you, or is a remote network, or is at home. A better understanding of how Wi-Fi works and how outside factors affect it will help troubleshoot what can be fixed and explain what is beyond fixable. Now, a single AP on the ceiling, it's easy to approach it as a single device, but in your wireless system, it's managed as multiple separate radios to handle different frequency bands. Each one has its own settings for channel, power, what SSIDs are broadcast, what its coverage area is, and the client utilization capabilities. In addition, when setting up and troubleshooting, we need to think of our access point beyond the wireless paradigm. It's also a client on the wired network. This is obvious, but it's also easy to forget when focusing on a wireless issue. The frequencies. As the band frequencies get higher, the effective radius shrinks due to signal propagation and absorption by the surrounding environment. That single AP hanging on the ceiling has somewhat different coverage pattern for each radio based on the frequency. Client data rates are affected by the received signal strength and how much noise they're hearing. Generally, as you get farther away from a radio, the signal gets weaker and your data slows down. Other factors, such as physical barriers, walls, etc., can obviously have an effect, but you can also have localized radio interference that adds noise, which makes the signal dirty, and your client will slow down the data rate to ensure data integrity. One note worth making here: the maximum data rates that marketers list for the equipment will only ever be achieved in the laboratory with pristine conditions. You may end up having to have conversations with your users explaining that their phone will never reach 3,000 gigabit connection speed that was promised. Data rates. Minimum data rates are, when you see that in your wireless settings, they're the mandatory data rates that a client radio must be able to use, or it cannot join the network. This can be used to prevent older devices from connecting and slowing down the network. However, this can be a design decision that later becomes a troubleshooting exercise if it's decided that an older client must be able to use the Wi-Fi. Hidden SSIDs. They are not a security solution. They violate the standard, except under very specific conditions. To find the name of a hidden SSID, an attacker only has to listen for a client to join, and in that process, the client will send the network name. Let's take a look at the RF bands. So 2.4 gigahertz has 14 total channels, with only the first 11 available in the United States. The others are available in different regulatory regions around the globe. The issue with the 2.4 gigahertz channels is that each of them is 20 megahertz wide, but they're only 5 megahertz apart. So many of the channels overlap, and if you use overlapping channels, it'll cause interference. It's best to use channels 1, 6, and 11, which will avoid causing adjacent channel interference. The 5 gigahertz band. This has more available channels, and in this space, it can be feasible to bond 2 channels together into a single 40 megahertz wide channel for more throughput. You still need to be careful of reusing channels on access points where clients attached to different APs are going to cause interference with each other. Another word of caution, some of the channels fall into the same radio range used by incumbents at airports and weather radar stations. These are the dynamic frequency selection channels, aka DFS. If your access point is on a DFS channel and here's a signal from an incumbent, there will be a minor disruption while the AP moves itself and its connected clients to a new channel. Use these channels, but use them with care. Many times in your wireless access system, you can look at channel changes that happen due to DFS interference, and that will help you figure out which channels you should exclude from your available range. The 6 gigahertz band is fairly new space and has been opened up by the regulatory agencies. The available channel count varies considerably based on your region. Generally, there's enough available space to comfortably use 40 megahertz wide channels, and you can even look at 80 megahertz wide channels, depending on how many Wi-Fi neighbors you have. Another bonus of this band is the lack of interfering devices you will have indoors. 2.4 and 5 gigahertz have been available to unlicensed use for years, and there are a lot of transmitters in their parts of the spectrum. This band does have incumbents, but they only affect outdoor access points. Outdoor access points are rated specifically for outdoor use, not just because of environmentally appropriate housings, but also because they follow the regulatory rules ensuring that they do not use licensed incumbent RF space. As you can see here, there's a considerable difference in the available channel space as you move through the bands, and why 6 gigahertz is so exciting. Looking at authentication for the wireless network. WPA2 has been around for a long time and is still considered secure, but it does have weaknesses you should begin planning to upgrade WPA3 if you haven't already. WPA3 has introduced greater security, and it remedies vulnerabilities in WPA2. The pre-shared key method used in WPA2 is replaced by simultaneous authentication of equals in WPA3. SAE uses stronger key generation techniques, and it ensures that each client has their own key. Opportunistic wireless encryption allows clients to have an encrypted session on open Wi-Fi networks that do not use a pre-shared key. This is a boon to clients who use Wi-Fi in public spaces where passphrases are eliminated for ease of use. Within WPA2 and WPA3, there are 2 modes available. Personal mode, which allows for open Wi-Fi or the use of a pre-shared key. And enterprise mode, which uses the 802.1x protocol and requires several back-end components, including individual user accounts. Now, we've talked a lot about the theory. I've talked a lot about the theory, but let's see how we can use that in practice. Now, PoE, it's a familiar concept, but there are interesting aspects when using it to power access points. CDP and LLDP are used to negotiate power requirements. Newer access points with more radios and higher frequency bands are becoming very power hungry. Most devices have a rated power requirement, and if it's supplied, they work. But if your switch only negotiates or only supplies a lower wattage PoE, the device simply doesn't work. Access points, however, will still power up, but with reduced functionality if they don't get their fully rated PoE wattage. They may power up for management, but the radios are down, or they will bring up some of the radios, but leave higher band radios turned off. So you get this interesting mix of my AP is powered up, I see the LEDs blinking, but I'm not seeing any SSIDs in the airspace, or my 2.4 and 5 gigahertz clients are connecting, but my 6 gigahertz client isn't seeing, or I'm not seeing any 6 gigahertz SSIDs available. When troubleshooting access point issues, look to see if it at least is powered up and can be managed. Is it reporting that some or all of the radios are turned off? Ensure that CDP or LLDP is enabled for use on the switch port connected to the access point. Check the switch and the wireless management system to be sure the access point is getting full power. Keep in mind that the cable category and the run length become more of a factor as delivered wattage increases. Longer cable runs and lower category cables can't carry the wattage as far, and they don't deliver the same amount of power to the end device. And don't forget to consider the standard wired device issues that can affect connectivity and performance of the wired connection to the access point. Now, troubleshooting authentication issues. These are some basics for any wireless network, but they can be obvious, but easy to brush past. If the user is typing in an SSID name, remember that SSID names are case sensitive. Strong passphrases and passwords are complex and therefore easy to have a typo. If a user is connected to the wrong SSID, they probably don't have the access they expect. For example, the user feels they don't need to go to IT to get onto the guest Wi-Fi, but they'll report that the wireless is broken because that employee can't get into the internal services while they're on the guest Wi-Fi. Personal mode specific issues have fewer pieces and are fairly straightforward. So just scope the issue. Is it one user typing a bad passphrase, or is everyone having trouble because they didn't see the email announcing a new passphrase? Do they have the correct passphrase, but are trying to use it on the wrong SSID? Enterprise mode is more complicated to troubleshoot because 802.1x has more components and more steps that can have issues. It often uses resources from multiple teams within IT that require coordination. The authentication flow may not be fully understood, and all you see is a failed login attempt. In 802.1x, there's some official and non-official roles that are involved. The supplicant is the user's client device. The authenticator, which for Wi-Fi is the access point. The authentication server, which is the radius server. Also, in the back end, there's a credential store, which is typically Active Directory or an LDAP server. These hold the user's credentials and don't have an official role in 802.1x protocol, but they can be part of an authentication process that might need to be troubleshot. Now this is the world's shortest introduction to 802.1x traffic flow process. You'll see the client tells the access point that it wants to join the network. The AP and the client shake hands. The AP tells the radius server that the client wants to authenticate. The radius server asks for the user's credentials. The access point asks the user for the credentials and then hands them to the radius server. The radius server asks the credential store if the credentials are valid. The store says yes, hopefully. The radius server tells the access point that they're allowed onto the network, and the AP tells the client they're allowed onto the network and accepts data traffic. Now, this is a grossly understated representation of the 802.1x process, and even so, you can see how many moving parts there are that can be involved in the troubleshooting. Now, even though this is a very minimized version of the process, it gives a sufficient overview to represent the troubleshooting waypoints, but I cannot overstate the importance of becoming familiar with the full process yourself. When troubleshooting enterprise authentication, think through all the component pieces and what they contribute to the process. Be aware of what teams within IT you'll need to work with for the various pieces, such as you may need to talk with the Active Directory team about the credential store functionality and whether the user has valid credentials. You may need to talk to the server management team to find out if there are any issues on the Radius server or the Radius service and if it's functioning. The basics still apply. Scope the issue. Is this happening to one user? If so, the steps are similar to pre-shared key troubleshooting. Check if they're using the right credentials and the right SSID. Also check to find out if their account is locked out or disabled in the credential store. If this is a problem that's happening to all users, is the link between the Radius server and the credential store down? Is the Radius server down? Has a certificate expired on a secured connection between servers? Did a shared secret between the Radius server and the credential store change on just one end? And then remember, logging in 802.1x and enterprise mode is your best friend. Get to know what good log events look like so you can spot trouble when things break. You'd be surprised at how many normal looking events are problematic, how many normal events look problematic the first time you see them if you're in the process of looking for a problem. So also, wherever possible, have syslogging enabled, log all of your data to your services to the syslog so you get the full picture and can watch the trail of the authentication process as it goes through all of the components for 802.1x. Interference issues. They can be caused by other Wi-Fi devices or by non-Wi-Fi devices on the same frequency, or other devices on the same frequency as the channel you're using. If you look at a Wi-Fi scanner and you see lots of overlap or overlap of strong signal, then you're going to be impacted. If you have non-Wi-Fi devices that use 2.4 or 5 gigahertz space, they could be causing the problem. If you have access to a spectrum analyzer that can listen on the frequency range you're seeing the issues on, the interference will be obvious. Without a spectrum analyzer, you may have to do more basic testing by powering potential interferers on and off to see if you notice the problems reproducing. Regardless of the type of interference, looking at retry rates will be your best indicator of how big the impact is. When data frames don't successfully transfer between the client and access point, they must be retransmitted. High retransmission rates will impact every client on the channel and slow the rate of data travel. At the end of the day, clients are the biggest factor in the performance of your wireless network. If a client sticks to the first AP it connects to when the user walks in the door and refuses to let go, even as the signal gets weaker and other APs are closer, the only solution is for the user to turn their Wi-Fi off and back on to force a reassociation. Legacy clients that use older 802.11 standards will slow down the whole network. The client device gets to pick which band it connects to when the SSID is available on multiple bands. This comes into play if you have a 2.4 gigahertz wireless available for older clients, and because of the channel restrictions, it doesn't deliver as far reaching, or there's some channel overlap, they might be joined to what's effectively a slower network versus going to the 5 gigahertz, which is right in the same access point because the client chose 2.4. Faulty drivers can cause everything from poor performance to OS crashes. Last summer, one of the major wireless vendors issued an updated driver that caused conflict with certain pretty common 802.11 protocols that were in use. And the only option that you had was to either downgrade every client, whether you could communicate to the client they needed to downgrade their driver or not, or turn off some of the features on your own wireless network until it was fixed. And that was purely what driver the clients were using. There's no other remediation that you could do on the wireless side besides turning off the feature. And remember, the client to vendor designs how their device operates, and it will optimize according to what they think is best for their customers, whether this is for the client to stay attached no matter how bad the signal is, or to constantly roam to the stronger AP signal, no matter how much the bouncing impacts connectivity. Now, as this has been an introduction to all these topics, there's a lot more nuance that can be used to make your troubleshooting easier. These resources listed here can get you started, filling the details, and even take you down the path of wireless certification. Now, these are resources that I used extensively going through my CWNP certification process. So lots of good content here. I can't say enough good things about the CWNP certification. Many of the certifications out there are vendor dependent. They talk about vendor solutions, how to implement vendor solutions, what nerd knobs to adjust on their wireless devices. But CWNP is truly vendor neutral, and it focuses on teaching you the technology, how to use the technology, and how to apply it. I hope I provided some useful tools for you, and I'm glad to answer any questions.
First, I gotta do a plug. I absolutely keep this in the drawer next to me at all times with all my bookmarks and flags and all that. So definitely a great resource and tool. So
absolutely. Yeah, and I've got the the CWNA Bible by the two Davids. I've got the version that I certified with, which is beat up and looks like it's about to fall apart. It's taped together. And I also bought the newer version because they do such a good job. You can just keep that on your desk, and you have it as a continual reference long after your certification is maintained or is achieved.
Yep. And then Paul's in the chat asking what the book was. I have this is a CWS study guide, but when we send out the slides tomorrow, you'll have all the resources that Charles just had on that previous slide. So you'll have all the books and podcasts. And of course, I also have to shamelessly plug the 7 Signal webinar playlist as an additional resource that you can peruse. But let's get into
I can also give a plug to Wi-Fi U. I used those extensively, the videos extensively on Wi-Fi U when I was certifying as well. It's a great place to find all the content broken up by category, and it's the hearing expert speakers talk about expert topics.
It's good stuff, man. It's good stuff. Let's get into some of the Q&A. So I'll look back and forth between the chat. If y'all have questions, put them in the Q&A panel. But I'm also going to keep an eye on the chat in case anything gets put in there. Okay, so there's going to be some of these that reference certain slides that you had, and this one is on that 5 gigahertz slide that was shown, asking if you could clarify what TDWR is.
Let's see here. Just shoot back to the slide, so let's take a look. There we go. TDWR. There we go. 5 gigahertz. Oh gosh, asking me to remember the acronym. I honestly don't remember off the top of my head.
I think isn't this the weather, the Doppler radar? Yeah.
Doppler weather radar. Yeah, I believe you're right. It being in the DFS channels is your leading indicator that it probably has something to do with the radar, and you're going to see them if you have one of those radar golf balls, weather radar golf balls in your area. You're going to see DFS channel activity. If you are near an airport, you're going to see DFS channel activity. So that it really, for instance, like I said, here in Syracuse, we've got an airport nearby. We've got a lot of hospitals. We have medical transports, and so when looking at what DFS channels do we use, because you don't want to lose in 5 gigahertz. That's if you take all of DFS out, that's a big hit. So I said we'll go in and we'll look at our RRM activity for issues where it bounced off of a channel because of radar. And so if you see it enough times, you pull that channel out of the rotation, but you can still keep using as many channels as possible.
Yes, and then to just confirm, thanks, Thomas. It is Terminal Doppler Weather Radar. That's like the official acronym.
Well, it drives me crazy because I love learning the acronyms, and there's always more.
There's so many in Wi-Fi. You got to make room for them in your brain somewhere. Okay, anonymous attendee. This one's a bit of a long one, so hopefully I can get through it without stumbling. Okay, could you please explain which Wi-Fi frames are sent at MBR and which are sent at data rates other than QoS data frames? There's like a second part to this, also asking to elaborate on how is part of one single Wi-Fi frame sent at MBR, for example, preamble, if I'm not wrong, and the rest of the same frame is sent at a higher rate.
Yeah. That it? Okay.
Yeah, that's it. That's
Making
it.
sure this is a great question. I like this. So yes, so all of the management frames are sent at MBR rates. So because the basic reasoning is everybody on the network has to be able to receive and understand the management frames. So if you've got a ready to send, a clear to send, just all of the data negotiation joins. You need everybody on the network needs to see those because they need to know if they need to back off, if they need to set their back off timer, if it's safe to send. So that's how this older clients slow down the entire network, because the bulk of your frames that you'll see when you analyze your network, it's mostly management frames. The data frames are bigger when they send, but more frames are sent filling the airspace of management frames. And yes, the beginning of the frames is sent at the lower rates so that the slower clients can see that, hey, I'm transmitting. This is an actual Wi-Fi transmission. And then the data portion of the frame can burst and send at a faster rate.
Very good. And even though Lee Badman is not here today, he's still here in the chat and in the Q&A panel. So Lee is here, hi Lee, asking, love this question, what minimal wireless training should non-Wi-Fi expert network support have? Something in-house, something through a vendor, CWNP? What are your thoughts, Charles?
Well, to plug CWNP, there is they've been changing them up a little bit lately, but there is the entry-level technician certification, which is a great place to start. I think every wireless technician should have a grasp of the fundamentals of wired networking. So maybe Cisco's popular, the ENT certification is a great primer. It's vendor centric, but it really covers the basics. You know, it talks about PoE. It talks about how packets travel, frames travel across the network. So I think every wireless technician needs to start out with an understanding of the wired network as the foundation. And then if you have a good, strong internal team, that's probably one of the best ways to train technicians on the wired side, because they're working with people they trust and they get to look at the live examples of what's relevant, what's not in their environment. And it builds that dynamic among the team, knowing that there's that mentor you can go to help. So if you can't do it though, if you can't do it internally, I would stick with the CWNP. I said in my chattiness before, the keeping it vendor neutral. You just look at some of the vendor materials and they really do dig it down into, here's the setting here's where the checkbox is to set which DFS channel you use, but they don't really talk to you about the pros and cons of using DFS channels. It's just as an example.
Yep. All right. Anonymous attendee here submitted in PSK. Can you please let me know why it is mentioned as fewer moving parts on this? This was on the simple auth issues slide.
Sure. So in pre-shared key methodology, the access point, the wireless environment has the SSID and has an assigned pre-shared key. And if the client has that right pre-shared key during the four-way handshake, it hands off the pre-shared key, the access point, or the backend wireless system, depending on how your wireless is built. Either the controller or the access point says, okay, you're on, you're good, you got the right key, or no, you got the wrong key, you can't. And that's simple compared to 802.1x, where, my long-winded explanation of the client tells the access point, I want to join. The access point says, well, who are you? And now it goes and tells the radius server, and two tells the credential. There's a lot of back and forth between all of those roles before you finally hear, okay, you're allowed to get on the network, because you have to talk, between the access point, the supplicant, the authenticator, the authentication server, and the backend repository. And it can become very nuanced. So you could have a user in an enterprise environment. Maybe their environment requires password changes every 90 days. And somebody comes in the morning and they're working just fine. Their wireless is connecting just fine. And 10 in the morning, their password changes, or their password disables in the credential store. They go off on a break, they come back and they can't log in because their wireless is refusing now. And it's all because there was that finesse of your account in the credential store timed out. So there's a lot more to troubleshooting. You have to look in a lot more places. And again, in larger environments, the person that does the wireless networking may not be managing the Active Directory or the LDAP server. They may not be running the virtual machines that the servers sit on. They may not be running the servers themselves. It may be an entirely different team. And then you have to coordinate, user reports, Wi-Fi is not working. Wi-Fi tech goes to it and they're just not logging in. Okay, so where in that chain, who do I need to talk to in that chain to walk through and find out? And again, shout out to logging. If you can look in the logs will tell you quite a bit about which part of the process tripped up the authentication.
I'm going to jump around just a little bit here. Steve Blunt asks, have you heard anything or rumors or fixes, vendor or IEEE, coming for IPSK or WPA3, for example? When, if ever, will it work?
IPSK, I'm not familiar. Is that the PSK per, or multiple PSKs in the SSID?
Let's see if anyone in the chat can help us out. We'll put a pin in that one. We'll come back to it. But if anyone in the chat can get some more clarification on that one. Let's move down to Raphael's question. If an AP is using channel bonding at 40 megahertz and all current clients are connected at 40 megahertz, if a client tries to join but only supports 20 megahertz, will the AP go back to 20?
That client will use 20 megahertz connections. It won't make use of the extra 40 megahertz. And another thing to be, this isn't what you asked, but another thing to be mindful when using bonded channels of any length. Let's say we've got we'll use the slide we've got up here. Say we're going to bond channel 36 and 40 as channel 38. And we're working along nicely. Everybody says, okay, we're on channel 36 plus 1, and we're operating nicely. And then an access point comes up that the access point only delivers 20 megahertz, and it sits on 40, channel 40. All the management frames from that bonded channel are going to go on 36. So things are going to negotiate, they're going to be able to connect, they're going to be able to do all the management frames, they're going to do all that. But when a client tries to send using the full 40 megahertz channel, they're going to collide with that 20 megahertz channel that's sitting on 40. So it's going to cause retransmissions and slow down. So it's not the question that was asked, but it's a little nuanced. Like I said, there's a lot of nuance to what I covered today, and I went through very briefly. If there's anything in here like these questions that you think, boy, that there's going to be questions, you're going to have questions, and definitely go out and research, and feel free to send Heather the questions. She'll pass them along to me. I'll be more than happy to answer after this too. I hope that answered the question.
Yes, Bruce, reiterating, wireless is all about nuance. My favorite answer to most questions that we get in the Q&A is, it depends. But okay, we got some clarification on IPSK. It's identity PSK, multiple PSK per one SSID, via various magics.
Yeah, I do have some experience with the multiple PSKs per SSID. Um, it's really going to be, work with your vendor to make sure that their solution does what you want it to do. I've had a lot of success with it. It's kind of a niche solution, but when it works, it's like, oh, it's like there's so many different things in IT. When you find that little one oddball solution that sits in the corner, you don't even need it for 90% of what you do, but that 10% that it fits for, it just fits perfectly. It helps prevent, one of the big things we do in wireless is constantly trimming down how many SSIDs we're broadcasting, because again, then you're back to your management traffic is taking over your airspace. So you trim your SSIDs down. Well, MPSK allows you to have that one SSID, but you can issue different pre-shared keys to different user bases, and that will shuffle them off to the VLAN that they need to be on.
Okay, just a couple more to get through. We're doing great. Kevin, did I understand correctly that more base stations will be needed with 6 gigahertz due to the shorter range in comparison to 5 gigahertz base stations?
It's up for debate, and honestly, it is like most issues related to signal propagation. It's very environmentally dependent. Okay, so 6 gigahertz is more easily absorbed by most common materials. So that, beyond the fact that it doesn't use, its useful propagation range is smaller, it gets absorbed more easily because it's a higher frequency. So that works against you. But you're really going to have to kind of see what works in your environment. In the environment I operate in, I haven't seen a lot of issue, but to be honest with you, the count of 6 gigahertz clients out there is still relatively small. So it's going to be more nuanced. It's not a general. You're going to have to increase your access points by 10%. There's no hard number around it. But again, I'm not seeing. It also depends on your initial deployment. Some initial, if you have a deployment where each client is typically seeing one access point at a time, you're probably going to see a bigger difference than the deployment where maybe everybody is within range of 3 or 4 or 5. The density of your deployment is going to make a big difference in that too. But in general, I'd say I wouldn't sweat it. I'd get yourself a 6 gigahertz capable AP, throw it into the mix, get yourself some reliable 6 gigahertz clients and try it out. But I'm not expecting a dramatic, oh my gosh, we have to double our AP count or anything ridiculous like that.
Okay. Let's do this one. Okay, can you explain why having a unique password for each user, WPA3, is more secure? Ultimately, wouldn't the password still be able to be used if that password was stolen?
So, all right, I'm gonna assume we're talking about WPA3 personal mode and the pre-shared key. And because that sounds like the situation we're talking about. Everybody still has the same passphrase, but the initial negotiation. So the passphrase is just your starting gate. Both devices take that pre-shared key and they use that to generate the actual keys they use for individual messages and group messages. So when in WPA2, everybody starts with the same passphrase. So if you, and it comes down and it generates the same key for each subkey for each client. So once I know the passphrase, I can go to anybody's session. So say I just put a collection node sitting in a coffee shop that has, the pre-shared key of coffee. I can go through and capture everybody's traffic and then decrypt it later on because I know the pre-shared key and the way WPA2 generates the keys. That one pre-shared key allows me to figure out decrypt everybody else's traffic. WPA3, everybody starts with the same pre-shared key, but then they generate their own subkeys. So even if I grab Charles's traffic and figure out how to decrypt it, through brute forcing or whatever. That's not going to work on Heather's traffic because Heather and the AP generated their own individual key from that same initial passphrase.
Makes sense to me. All right, last one from Lee Badman. This is a really great way to end. But what are some basic tools that anyone supporting wireless needs? Like not experts, just first level responders.
So every operating system comes with some tools that can give you some basics. Windows, I'm most familiar in Windows, the netsh command. So you can netsh WLAN. There's a whole subset of commands in there. You know, for instance, netsh WLAN show interfaces will tell you what BSSID AP you're connected to, what your connection speed is, what protocol, which 802.11 protocol you connected at, what your encryption protocol is. You know, and it might be more information than you need, but you can start seeing, okay, this client is clearly connected to the wireless network. It's not a wireless issue. You can move on. This, you know, it's astounding how many wireless network issues have nothing to do with the wireless. You know, you go in and look in the system and you're connected just fine. So your base tool set is, are you connected? Are you connected in the frequency you're looking for? The Mac, I know up in the toolbar in Mac, you can drop down and it'll show you your signal strength level, your signal noise ratio, what channel you're on. It'll show you a lot of that same information that you see from netsh WN on Windows. There's a lot of free tools. Wi-Fi Explorer Pro, the screenshot that I gave there to show RF interference or signal interference from Wi-Fi, that's out there. Looking right now to see another one that I have. Android has Wi-Fi Analyzer, and these will, you know, these tools will show you what your Wi-Fi environment looks like around you, who's using what channels, what channel are you on. You know, you'll very often, especially when you get in the 5 and 6 gigahertz, go home, you know, get Wi-Fi Explorer Pro, get Wi-Fi Analyzer, get something like that, and open it up and look at your neighborhood where you've got all your neighbors. You'll find the Wi-Fi channels are like magnets. Everybody wants to cluster on the same set of things. And then over here, a little further down the channel frequencies, it's wide open. You reset your access point to go over here and you watch your speed increase for free.